this video, I'll show you how to solve the ALEKS problem called using molarity to find solute mass and solution volume. There are two different versions of this problem, and I am going to show you how to solve both of them in this video. So this problem involves using or performing a molarity calculation. Let's just start by writing out that equation that we're going to use to solve this particular problem. The molarity of a solution is calculated by taking the moles of a solute and dividing it by the volume of the solution in liters. So actually, instead of writing volume, I'm just going to write L for liter. It's really important that you use that unit. In this ALEKS problem, you're going to be given two of these three variables, and you're asked to solve for the third. Now, every single version of the problem that I looked at provided you with the unit of, or the value of the molarity. Every version that I looked at was asking either for you to calculate the moles or calculate the liters, one or the other. So this form of the equation is not super useful for solving this problem. Instead, you're going to want to rearrange this equation into something that is more useful. So for example, we could do cross multiplication with this equation if we wanted to, and we could say that the moles of a substance is equal to the molarity times the volume in liters. This would be a great version of the equation to use if ALEKS was asking you to calculate the moles of a substance. Another version of the problem asks you to calculate the volume. If you're being asked to calculate the volume, we could rearrange this equation one more time to isolate the volume, isolate the liters. That's going to be moles divided by molarity. So what you're going to want to do, you're going to be using one of these two versions of the equation. I'm just going to kind of cross this out because, again, this form of the equation is not going to be useful for the problem. So what you're going to want to do is take a look at the problem that you've been given and identify the values, the numbers that ALEKS has provided to you. So you can see here, I have 1.25. That is my molarity. Molarity, the units are actually moles over liter. So in some versions of this problem, ALEKS is using the capital M as the molarity, but in other versions of the problem, like mine, it's using moles over liter in place of molarity. So ALEKS is providing me with the molarity. It's providing me with this value or this value right here. And it's also providing me with the value 100 grams of my substance. I'm not worried about what it is yet. So it's giving me a mass. Now, if you look carefully, there is no mass in any of these equations, so we're going to have to think about that. But what I want you to do is identify the variables that ALEKS has given to you, and then also identify what ALEKS wants you to figure out. I'm going to use a different color for that. So it wants me to calculate the volume of this substance. So of these two equations that I have available to me, this equation is going to be the most useful because this is the equation that solves for liters, which is a unit of volume. So to use this particular equation, I am going to be plugging in the number of moles, dividing it by the molarity. Now I know for sure what the molarity is. It's this 1.25 moles per liter. But I don't have the number of moles. What I do have is the mass. And this seems to be pretty consistent with this particular ALEKS problem, where even though the number that you actually need to use is the moles, ALEKS is giving you the mass instead, and you need to do a mass to mole conversion, which is fine. We can do that. So we're going to do that conversion up here. 100 grams of AgClO4, and we're going to convert that into moles. So we want a conversion factor that has grams of AgClO4 down on the bottom so that unit cancels. We want to convert into units of moles of AgClO4 up top. And this relationship is the molecular weight of AgClO4. Now, you probably know how to calculate the molecular weight, pull a periodic table out, and add up the masses of all of these atoms. A faster way to do it is just look it up on the internet. Molecular, that is not spelled correctly, molecular weight AgClO4. Be careful when you're looking this up because Google does have a tendency to think that you mean something else. So I've got this pulled up, 207. I am double checking and looking at the Lewis structure over on the side to make sure that it actually is AgCl4 and not something else like AgCl3. 207.319 grams per mole. That saves a lot of time. I already forgot what it was. 207. I'm just going to use 207. grams per mole. And this is going to allow me to do that gram to mole conversion. 100 divided by 207 is 0.483 moles. Now, why did I have to do that? Again, why was that necessary? Because I am trying to use this equation right here to calculate for the volume. To use this equation, I need to know both the moles and molarity. The problem gave me molarity. The problem gave me mass, and I had to convert the mass into moles. 0.483. So we are just going to finish this out. And my answer is 0.386. My unit is liters. By default, when you're doing this problem, the unit of the volume is going to always come out in units of liters. Before you dump your answer into the answer box, double check and see what answer or what unit ALEKS wants you to be expressing your volume in. Mine, it wants to be expressed in units of milliliters. So that means I need to do one more conversion where I convert from liters into milliliters. Milli is the prefix for 10 to the minus 3, so 1 milli is 10 to the minus 3 liters. My liter unit will cancel, and I'm going to end up with 386 milliliters. Now for the other version of the problem, you're going to be using this equation right here. ALEKS is going to provide you with the molarity, and ALEKS is going to provide you with a volume. The volume might be in liters, but it might be in milliliters. Whatever the volume is, you need to make sure that you get that volume converted into liters. So the volume in liters. Now in the version of the problem, this version of the problem, where you're being provided with the volume, ALEKS is probably not, the problems that I looked at, ALEKS wasn't actually asking us to calculate the moles. ALEKS was actually asking to calculate the mass, or grams. Remember that anytime you know the moles, you can easily convert the moles into grams using the substance's molecular weight. So if you're being asked to calculate the mass, this is actually the equation that you want to use. You're first going to get moles, and then you're going to convert those moles into grams using a process like this one up here. Let's just pretend like I've got this version of the problem. Let's just kind of change stuff up a bit. And let's just say that I was told that this, instead of 100 grams, I was told that I had 100 liters, and I was being asked to calculate the mass in units of grams. So how would I set that up? I would use my molarity, 1.25 moles per liter. I would multiply it by my volume in liters. That would give me 125 moles for this particular problem. 1.25 times 100, those liter units cancel. And if the problem was actually asking me for the mass in grams and not the moles, I would need to do one more conversion factor where my mole unit cancels and I convert into grams, still pretending like I'm using the AgClO4 molecule. And I'm going to use the molecular weight that I looked up on the internet. 207 grams is 1 mole. We would just do one more multiplication here, and that would give us the answer.